Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we'll be learning about point reflections. So for the DUNA, we have the following problem. Given that point A is 1, 2, point B is 5, 5, and point C is 5, 2 in a triangle ABC, what is the composite reflection first over the y-axis, then over the x-axis? Remember, as we learned in the previous video, that when you do a composition of different transformations, you actually read it from right to left. So first you're reflecting over the y-axis and then over the x-axis. So let's look at this in the graph. So here we have the given triangle with the given coordinate points as shown in the figure. Now, if we reflect it first over the y-axis, we obtain the following image of triangle ABC, namely triangle A prime, B prime, C prime with the shown coordinates of A prime to be -1, 2, B prime to be -5, 5, and C prime to be -5, 2. As discussed yesterday, when you reflect a point over the y-axis, you're just negating the x coordinates. Then we reflect over the x-axis. Now, what happens to the coordinates of A prime, B prime, and C prime? Well, in this case, we're just negating the y coordinates to obtain the following image as shown in the figure. So after you reflect over the y-axis, you obtain the following image of A prime, B prime, and C prime, namely A double prime to be -1, -2, C double prime to be -5, -2, and B double prime to be -5, -5. Now the question is, how can we describe this type of transformation as one single transformation? So if you, for example, had to ignore A prime, B prime, and C prime, how can we get from triangle ABC to triangle A double prime, B double prime, and C double prime in one single transformation? Well, there are different types of transformations that you can perform here. But one of them is a point reflection over the origin. So let me show you what I mean. In this case, you could reflect every given point over another point. For example, as you can see, point A, if you reflect it over the origin, then you obtain a double prime. And similarly for B, you reflect that over the origin, you end up with B double prime. And for C, you reflect that over the origin to obtain C double prime. Now, based on this example, there are many things we can now deduce from point reflections. For example, we could come up with a definition of a point reflection and with a specific rule. So let's do that. So imagine you have a point P here, somewhere here it's P, and let's say you have another point Q over here, okay? And let's say you wanted to reflect that point over to obtain PP prime. So in this case, what you can do here is reflect point P over Q, so you can actually measure the distance and reflect it over onto the other side. So I'm going to draw a dotted line here. So again, that's just an approximate sketch. And in this case, we end up with P prime, the point being reflected over point Q. So what must be true in this figure? Well, what must be true is that these two segments are congruent, and therefore Q becomes the midpoint of the segment defined by P and P prime. And that is basically the definition of a point reflection. So the definition states that the image at P is reflected in another point Q is defined so that Q is the midpoint of segment P and P prime. That is the definition of point reflections. So later on, you might want to even use the midpoint formula to calculate certain point reflections. And I'll show you in a bit how we can use the midpoint formula. So what is the general rule now? What happens if you reflect a point, so let's call it point x, y, over the origin of, let's say, point Q in this case, then what are the new coordinates of P prime? Well, let's go back to the original example. Well, what do you notice here? So let's say we take point A, okay, and let's say we're reflecting point A, which in this case is 1, 2, and we're reflecting that point over the origin. So the way you denote it is to put a circle as a subscript for lowercase r. We end up with point, and if you look at here the diagram, -1, -2. Okay, so let's write this better, -1, -2. And as you can see, we're actually negating both the x and the y, okay? So as a general rule, we can state the following, that the reflection of a point xy, or any point with coordinates xy over the origin, then the image will be -x, -y. And that actually makes sense because we just learned that a point reflection over the origin is the equivalent of reflecting a point first over the y-axis and then over the x-axis, or vice versa. So let's look at another example now. Let's take the same points of the original triangle with A, B, and C. What is the reflection of those points over not the origin now, but over another point of -1, 1? Well, how would you do this? Well, first, it's better to visualize this, okay? So let's say that you have a point A here somewhere. Let me call it point A. And somewhere here we have that point, which is -1, 1, okay? So from this, we know that that is going to be reflected over that point -1, 1. So basically, you draw this, okay? So that's the reflection. These two are congruent, and we end up with a point, which is A prime in this case. So this is going to be 1, 2. Again, by the definition, this is now the midpoint, okay? So what we can do here is utilize the midpoint formula. And how would you do that? Well, according to the midpoint formula, we know that the midpoint is defined as x1 plus x2 divided by 2, comma, and then we have y1 plus y2 over 2, okay? So in this case, for example, we can call this to be x2, y2, and we know that 1 and 2 are x1, y1, respectively, okay? And we have the midpoints. So what we can do here is say that -1, 1, that is equal to, or the midpoint is equivalent to x1, which is 1, plus x2, which is the unknown, divided by 2, comma, and now we have y1, which is 2 plus y2 divided by 2, okay? And now we just need to solve for this. So if we solve it, we write that -1 equal to 1 plus x2 over 2, and we know that 1 has to be equal to 2 plus y2 over 2. That means that -2 here has to be equal to 1 plus x2, and in this case, 2 equal to 2 plus y2. So that means that x2 in this case is going to be what? Well, so subtract 1 on both sides, you end up with -3. And y2 is just going to be 0. Okay, we actually just found A prime, which is -3, 0, okay? So you can actually repeat this for point B and C as well. So I leave you to do that as an exercise. But let me show you how this would look like graphically and what the points will be. Okay, so here's the graph. So as you can see, we did calculate previously here A prime to be -3, 0. And you can clearly see it over here, okay? So -3, 0, which is this point A prime. So again, you repeat the process, and you can do this algebraically. For B prime, you should get -7, 3. And for C prime, you should get -7, 0, okay? So that's basically how you do a point reflection, okay? Remember, if it's over the origin, you just negate the x and y coordinates, and if the reflection occurs over a point other than the origin, then you must use the midpoint formula. So I hope you enjoyed watching this video. If you have any questions, please leave a comment in the comment section of this YouTube video. Otherwise, please don't forget to subscribe and like the video, and have a fantastic day.